For decades, the answers came in pieces. Scientists understood the basics, divers knew the upper walls, explorers had already linked it to an ancient cave system. Jacques Cousteau helped make it world famous in the 1970s, but fame is not the same thing as understanding. There is a place in the Caribbean where the sea opens into a near-perfect dark circle almost 300 meters wide. From the air, it looks like a missing piece of the planet. Below the bright reef, the water drops into a pit more than 120 meters deep. And for years, almost nobody knew what waited at the bottom. Divers could visit the upper edge, but the lower world stayed hidden in darkness. Then, a modern expedition finally went down far enough to see it. And what they found raised a bigger question than the hole itself ever did. Picture yourself flying over Belize on a clear day. Below you, the ocean shifts through impossible colors. Pale turquoise, deep green, sharp white reef lines. And then, all at once, that circle appears. Dark blue, clean-edged, almost too perfect to be natural. It sits inside Lighthouse Reef Atoll, around 60 miles off the coast of mainland Belize. The reef around it is shallow and bright. The hole at the center is not. It looks like someone drilled straight through the Caribbean and never filled the space back in. That contrast is why the Great Blue Hole became famous long before most people knew much about it. You do not need to be a diver to feel its pull. One look from above, and your brain starts asking the same question. What is that doing there? That is the strange part. Millions of people had seen the Great Blue Hole in photos. Thousands had visited it. Yet much of its deeper interior remained only partly known. You could say it was one of the most recognized places in the ocean, and still one of the least personally seen. And that matters because the Blue Hole is not just beautiful. It is a record, a physical memory, a place where rock, water, chemistry, and time all meet in one dark shaft. If you read it carefully, it can tell you what this region looked like when sea level was far lower than it is now. Imagine standing here not with fins and tanks, but on dry limestone thousands of years ago. No turquoise lagoon, no atoll as we know it, no circular abyss full of seawater, just land, cave chambers, dripping mineral-rich water, and a roof above your head. That sounds impossible now because today the hole lies beneath open ocean. But that is exactly the point. The Great Blue Hole was not born underwater. It became underwater, and that shift is part of what makes the place so powerful. You can still see clues near the top. Divers descending into the Blue Hole often talk about the mood change first. You leave bright reef life behind, the walls sink away, the blue deepens, sound seems to thin out. Even before the real darkness begins, the place already feels separate from the world above. But here's the first small mystery. If the hole is just an old flooded cave, why does it look so sharply defined from above? Why is its shape so striking compared with so many other coastal features that erode into messy edges and broken lines? That clean circle is part geology and part collapse, but it also hints that the story was not one simple event. And then there's another detail people often miss. The hole is not empty space. We tend to imagine it like a giant smooth well. It is nothing like that. Inside are shelves, ledges, overhangs, mineral formations, sediment slopes, and chemical layers that divide one zone from another. It is less like an open shaft, and more like a drowned building whose rooms were broken and buried. That is why the 2018 expedition mattered so much. It was not just a sightseeing trip with famous names attached. It was a deliberate attempt to map the interior in detail and finally look at the parts that normal recreational diving could not safely reach. The team wanted more than dramatic footage. They wanted structure, evidence, a true picture. The expedition involved Aquatica submarines, explorer Fabien Cousteau, entrepreneur Richard Branson, and pilot and ocean explorer Erica Bergman, among others. Using small submersibles and sonar, they aimed to create a three-dimensional map of the hole. That sounds technical, but the goal was simple. See the place properly for the first time. And that is harder than it sounds. Water steals light quickly, depth brings pressure, visibility changes. Fine sediment can rise and turn everything cloudy. A place that looks wide open from above can feel close and strange once you are inside it. Every meter down, the blue hole becomes less like a postcard and more like another planet. So now imagine dropping below the surface in a submersible. The bright ring of reef fades above you. Fish still move through the upper water. Light still reaches the walls. At first, you might think the hole is giving itself up easily, but it is not. It is only letting you in. The first phase of descent is almost deceptive. The water is still blue. The shape of the walls still makes sense to your eyes. You're moving through a famous dive site, yes, but it still belongs to the normal ocean. Coral life survives nearby. Reef animals pass along the upper rim. The Caribbean is still present. Then, the walls start to say something older. Long before the submersibles reached the deepest parts, explorers already knew that the blue hole was linked to cave formation in limestone. Limestone is rock that can be worn away by water over huge stretches of time. Bit by bit, cracks widen, chambers form, roofs weaken. Whole cave systems can grow inside what looks solid from the outside. During past ice ages, sea levels were much lower, so low, in fact, that areas now underwater were once exposed land. That matters here because a dry cave can grow stalactites. An underwater chamber cannot. Water dripping through a cave ceiling leaves behind mineral traces. Over many thousands of years, those traces build downward into stone points. So if you ever find large stalactites deep beneath the sea, one thing is certain: they did not form there underwater. They formed when that space was dry. That idea had been part of the great blue hole story for years, but a theory hits differently when cameras and sonar finally show you the evidence in place. It is one thing to say the hole was once land. It is another to descend into the dark and face the stone-proof yourself. The expedition set out to map the walls and interior shape in high resolution. Sonar became the team's second eyesight. Where the human eye struggles with darkness and distance, sonar can sketch the hidden outline of walls, shelves, and formations through sound. In a place like this, that changes everything. Think about what that means. For decades, people had stories about the blue hole. Divers had fragments. Researchers had models. But now, for the first time, the hole could be turned into a full three-dimensional form. Not just myth, not just memory. A measured space. And the more the team looked, the more the hole began to reveal its history in layers. Terraces along the walls suggested pauses in ancient sea level rise. Some surfaces had been eroded when water sat at one height for long periods. Other sections were steeper and cleaner, hinting at faster changes. That is one of the hidden powers of a place like this. It does not just show you a cave. It shows you timing. It shows rhythm. It suggests that the ocean did not rise into one smooth, gentle motion after the last ice age. In some periods, it may have climbed in steps, fast enough to leave dramatic marks. Now stop and picture that. Not a calm shoreline slowly creeping inland year after year. Think bigger. Think coastlines changing within lifetimes. Think land becoming seabed. Think a cave system losing the sky and taking in the ocean. That alone would make the Great Blue Hole worth studying. But the expedition had not yet reached the most unsettling part. As the submersibles moved deeper, they encountered features that broke the simple idea of a smooth sinkhole. Sediment had piled into berms. Slopes had formed where material poured inward over time. In places, the bottom was not the flat resting floor people might imagine. The hole had internal shape and motion even in apparent stillness. This is where the scene starts to change in your mind. The blue hole is no longer just a circular pit. It becomes a dynamic archive. Sand moves, shells fall in. Currents, wind-driven wave action, and gravity keep reshaping parts of it. Even in silence, the place is active. And then came one of the eeriest sights reported from the deeper zone. A stretch littered with conch shells. Not one or two, many. A kind of underwater graveyard. Some appeared to show tracks where the animals had tried to crawl upward before failing. That image matters because it tells a simple story with no need for drama. Creatures can fall or wander too close to the steep inner edges. Once down in certain zones, they may not escape. The walls are too steep. The conditions below are too hostile. The hole becomes a trap. A trap for what, exactly? That question leads us to the next shift. At around 290 to 300 feet down, the expedition documented a layer of hydrogen sulfide in the water. You cannot think of this as just a line on a chart. It is more like an invisible border. Above it, reef life still exists. Below it, oxygen drops away until the bottom becomes anoxic, meaning there is essentially no oxygen left for animals to breathe. That is the moment the blue hole stops feeling like an unusual dive site and starts feeling like a divided world. One part belongs to the living sea, the other does not. Erica Bergman described that layer as cutting out the light and marking the start of total darkness below. That is a hard thing to picture until you imagine looking up from inside the hole and seeing the bright circular opening above while the world around you turns black. Not blue-black, black. You and I are used to the sea as a place of motion and life. Fish, coral, sound, current. But beneath that layer, the blue hole becomes still in another way. It becomes chemically different. It does not welcome passing bodies. It preserves them. That is because normal decay needs oxygen. If something sinks below the hydrogen sulfide layer and decomposition uses up the remaining oxygen, the process changes. Without oxygen, life does not continue there. And the breakdown of the dead does not continue in the usual way either. This is where the story sharpens. Because once you understand that chemistry, you understand why the hole can keep things. And not just shells. The expedition also located the remains of 2 divers who had gone missing there years earlier. The team reported the discovery to local authorities, and the remains were left undisturbed. Bergman later spoke about that moment with restraint, not spectacle, not shock, just a quiet acknowledgement that the missing had been found. That changes the emotional weight of the whole place. Up to that point, the blue hole can seem like pure geology and mystery, ancient cave, changing sea levels, toxic layer, strange silence. But then the human story comes back hard. This is not only a natural wonder, it is also a place where people have vanished. And when you know that, every part of the descent feels different. The beauty from above is still real. The science is still real. But now the hole carries grief too. It also carries uncertainty, because the team reported seeing odd marks in the sediment near the bottom. Circular, crisscrossing tracks that were not immediately explained. And here is what matters most about that detail. The expedition did not force an answer. That honesty is rare and valuable. In a story like this, it would be easy to turn unexplained marks into a wild claim. Some unknown creature, some hidden machine, some buried relic. But the real team did something more interesting. They said the origin remained open to interpretation. That phrase may sound less exciting at first. It is not. It is more exciting because it is how real discovery feels. You see something, you document it, and you admit the gap between sight and certainty. That gap is where good science lives. So what could those marks have been? Possibilities have been suggested. Sediment movement, contact from dropped or dragged equipment, old disturbances shaped over time, but none of those ideas have been firmly confirmed as the final answer. The marks remain one of the small open loops at the heart of the blue hole, and every strong story needs one. By now, you can feel the rhythm of the place. First the bright, famous image from above, then the geological backstory, then the deepening darkness, then the chemical boundary, then the preserved remains, then the unexplained traces at the bottom. Every layer answers one question and opens another. But that was not even the strangest part, because the most important revelation was not the darkness itself. It was what the walls inside the hole said about time. Near the lower depths, the team documented stalactites and evidence of cave structures that should not exist in an underwater shaft, unless the space had once been dry. That is the smoking gun of the blue hole's past. Stone does not care about our confusion. It records what happened anyway. Picture a wall of mineral formations hanging in a place now filled with seawater. Some are huge, some are coated by later growth from their life underwater, but their basic shape gives them away. These are cave features, dry cave features, the fingerprints of a vanished landscape. Now slow that image down. Try to hold both versions of the place at once. The first version is ancient. Dry ground, cave roof overhead, water dripping for thousands of years. Stalactites lengthening grain by grain. The second version is modern. Open ocean above. A reef ring, darkness below, submersibles drifting through a drowned chamber. The same place. Two worlds. That is the turning point in the whole story. Not because it is flashy, but because it collapses time in front of you. Suddenly, the blue hole is no longer just a deep dive site with eerie chemistry. It is proof that the boundary between land and sea can move on a scale so large that whole cave systems become seabeds. And there is more. Some of the stalactites documented there are not perfectly vertical now. They appear tilted. That matters because stalactites grow downward under gravity. If they are no longer aligned the way they formed, something changed after they grew. Exactly what changed is still debated in detail, but the basic lesson is clear. The cave system did not simply form and freeze in place. It shifted, collapsed in stages, possibly responded to later structural movement. The blue hole's history was dynamic, not neat. That should make you pause for a second. We often want nature to give us a clean story. First this happened, then that happened. But real landscapes are messier. Roofs weaken, water levels shift, sediment buries old surfaces, pieces move, new conditions overwrite old ones without fully erasing them. The Great Blue Hole preserves that mess, and because it preserves it, it teaches us something bigger than itself. We talk about sea level rise today as if it is mostly a future story. But inside the blue hole, you are looking at physical proof that sea level has already changed dramatically in Earth's recent past. Not in the age of dinosaurs, not in some unreachable deep time haze, in human-relevant geological time. That does not mean the ancient world and the modern world are identical. They are not. But the hole is a reminder that coastlines are not permanent. Shorelines move. Land becomes ocean. The map we inherit is not the map the planet owes us forever. And the hole tells that story in a way charts cannot. A chart shows a line going up or down. The blue hole shows a cave drowning. That is why the discovery of the stalactites hit so hard. It gave a visible, almost emotional anchor to an otherwise abstract process. Rising seas are one thing when you read the phrase. They are something else when you find a dry cave feature hanging hundreds of feet below the modern surface. The deeper explanation begins there. Let's break it down simply. During the last glacial period, large amounts of Earth's water were locked in ice. That lowered sea level globally. In exposed limestone regions, rain and groundwater slowly dissolved rock, creating caves and chambers. The future Great Blue Hole was part of that dryland world. Inside those caves, water dripping from the ceiling left behind minerals. Those deposits grew into stalactites from above and stalagmites from below. This takes a long time. Not years, not decades. Thousands upon thousands of years. The cave had time. Then climate changed. Ice melted, sea level rose. As the sea pushed inland and upward, low-lying cave systems flooded. Once a cave loses its dry airspace and fills with water, stalactite growth stops. The cave enters a new life. Eventually, parts of the roof collapse. If enough roof gives way, the surface opens. A sinkhole forms. Flood that sinkhole with seawater. Widen the shape, bury parts of the lower cave under sediment, and you begin to get something like the Great Blue Hole we know today. That is the broad script written by the rock itself. But the hole adds details. Terraces along the wall may mark old sea level stands. A reef-related layer around the 290-foot zone suggests a time when coral growth occupied shallower conditions there. Sediment berms hint at later infill and transport. Everything inside the hole speaks to change over time. And then there is the hydrogen sulfide layer. That part is geology's dark partner. It is not about how the hole formed, it is about how the hole behaves now. Hydrogen sulfide is produced by bacteria in oxygen-poor conditions as they break down organic material in certain chemical pathways. If you strip away the technical words, the key idea is simple. In some trapped or poorly mixed waters, decay and chemistry can create a hostile layer that most familiar sea life avoids. Inside the blue hole, that layer forms a dividing boundary. Above it, sunlight still supports a recognizable marine world. Below it, the chemistry changes so much that oxygen disappears. The deeper zone becomes anoxic and largely lifeless. That explains the conch graveyard. It explains the preserved debris. It explains why bodies below that level do not decay in the ordinary way. The bottom of the hole is not just deep, it is chemically cut off. Now ask yourself what that would feel like inside a submersible. You're descending through Caribbean blue. Then the light begins to fail. Then you enter a layer that shuts the upper world away. You look around, and the familiar signals of life are gone. No moving fish, no reef color, just rock, darkness, and preserved traces. It must feel like crossing a border no animal was meant to cross casually. That is one reason the blue hole can feel more alien than open, deep ocean. In open water, depth often means distance. Here, depth means enclosure. It means walls, layers, a ceiling of bright water far above. You're not only going down, you're going into something. The expedition's sonar work was crucial because the human mind struggles to understand enclosed underwater spaces without a full map. We imagine them too simply. Sonar corrects that. It can reveal ledges, vertical drops, filled-in sections, ridges of sand, trenches beside the walls, and the overall architecture of the chamber. Some reported observations suggested sand had built into a high berm in parts of the hole. That makes sense when you think about how material can be driven inward over long periods. Wind and wave action above, plus gravity below, create a slow conveyor belt. The hole does not merely sit there, it collects. And what it collects says a lot about the world around it. This is also why the discovery of plastic and other human debris mattered, even if some reports emphasize that the hole was relatively free of trash compared with what many might fear. The point was not only how much waste was present, the point was that any waste was there at all. Think about that. A formation created over enormous spans of natural history. A place difficult to reach. A place famous precisely because it feels remote and untouched. And still, human-made debris finds its way to the bottom. The contrast is brutal. One bottle, one line, one piece of discarded gear does not sound like much when you say it fast. But in a place like this, each item feels louder. It reminds you that there is no true away. Things we drop or lose or throw aside keep traveling. Sometimes they end up in the last places we expected. There is another lesson hidden in the Great Blue Hole, and it has to do with scale. From above, the hole looks self-contained, like an isolated feature, but the science suggests it is part of a much wider story that includes other marine sinkholes around the world. Belize's blue hole is not the only blue hole on Earth. Similar formations exist in places like the Bahamas, the Red Sea region, and the South China Sea. They differ in size, depth, shape, and setting, but the family resemblance matters. Each can preserve clues about past landscapes and sea levels. That is why comparisons matter. If terraces in Belize line up broadly with features in other blue holes, scientists gain a stronger record of how water levels shifted over time. One hole may tell a local story, many holes together begin to tell a global one, and that shifts the Great Blue Hole from tourist icon to scientific reference point. It stops being just a famous circle in the sea and becomes part of a network of evidence. Yet for all that science, the place keeps its emotional force. Maybe that is because the blue hole sits at the meeting point of so many different feelings: awe from the aerial view, claustrophobia from the descent, respect for the geology, unease at the chemical boundary, sadness at the human losses, frustration at the trash, curiosity at the unexplained marks. Few places can hold all of that at once. Now imagine being on the support vessel during the 2018 expedition. The submersible is down, sonar data is coming in, Every pass adds detail to a place that resisted easy understanding for decades. Above deck, you're in sunlight and salt wind. Below, in darkness, your team is drifting through a drowned cave. That split between surface and depth is part of the magic of ocean exploration. So much can happen beneath calm water. A perfectly still sea can hide cliffs, chemistry, silence, and history greater than anything on land nearby. The Great Blue Hole is almost a symbol of that truth. And yet the story still circles back to one very human question. Why do we care so much what is at the bottom? It is not only because we want to reveal, it is because hidden spaces make us measure ourselves against time. The Blue Hole reminds us that most of the world was here before us, and much of it keeps records we have barely started to read. When a submersible finds a wall of stalactites underwater, it is not discovering magic. It is discovering humility. The world has changed more than our daily lives allow us to feel. Landscapes we call permanent are temporary on the scale the planet uses. That is also why the unresolved details matter. The strange tracks in the sediment were never inflated into a fake answer by the people who actually saw them. That restraint gives the whole story credibility. It tells you that the real findings were strong enough on their own. And they were. A drowned cave system, evidence of major sea level change, a sharp chemical border with no oxygen below, a preserved graveyard of marine life that strayed too deep, human remains resting in dark water after years of uncertainty, and a few marks that still do not fit neatly into the picture. If anything, the lack of total closure makes the place feel more real. Nature does not owe us a finished script. There is something else worth saying here. The Great Blue Hole is often framed as a mystery first and a science story second. But the truth may be the opposite. Its deepest power comes from how science makes it even stranger, not less strange. Think about that for a second. The real story is not smaller than the sensational version. It is bigger. The hole was once dry land. The sea rose and swallowed it. The cave roof collapsed. Chemical layers formed that separate life from death in the same shaft of water. Rock formations still hang where air once filled the chamber. That is all true, and it is stranger than most fiction. You do not need to invent monsters when the Earth has already done this. And you do not need to invent lost cities either. The real artifact down there is the cave itself. The actual treasure is the record it carries. In a world obsessed with fantasy reveals, the Great Blue Hole offers something more durable, honest wonder. That is why it still pulls people in. Not just divers, not just geologists. Anyone who has ever looked at a map and felt that small electric question, what happened there? The answer, in this case, is both ancient and immediate. Ancient because the main forces at work span ice ages, cave growth, collapse, and long sea level change. Immediate because the site still speaks to the present. Modern ocean science, pollution, risk, conservation, climate conversations, human curiosity itself. And still, the strongest image might be the simplest one, a dark circle in bright water. That is how most people meet the Great Blue Hole. They do not meet it through sonar models or chemistry data. They meet it as a shape, a visual riddle. Maybe that is why it has lasted in the public imagination so well. Before you know anything, you already feel that it means something. Then the science comes in and deepens the feeling rather than taking it away. By the end of the 2018 expedition, the Blue Hole was no longer just an icon seen from above. It had become a mapped interior space with specific features and documented layers. That does not mean every mystery vanished. It means the mystery matured. The unknown became more precise. We now know more clearly that the Blue Hole records a drowned cave history. We know more about the anoxic lower zone and the hydrogen sulfide boundary. We know more about the internal structure and terraces. We know that the bottom held signs of human loss and human impact. We know enough to ask better questions next time. And there should be a next time. Maybe not in the same exact way, maybe not soon, but places like this repay careful return visits. Every new tool changes what can be seen. Better sensors, better mapping, better comparisons with other blue holes, better understanding of how these systems evolve. The Great Blue Hole is not finished as a scientific story. No important place ever is. That matters for Belize, too. The hole sits within the Belize Barrier Reef Reserve System, a region of major natural value. It is not a disconnected oddity. It belongs to a living, broader environment. Reef health above, chemical extremes below, and global attention all meet in one location. Conservation here cannot just be about preserving a famous dive photo. It has to include the larger ecosystem around the hole and the human behavior that affects it. The fact that even a remote natural wonder can receive plastic and debris is warning enough. Fame does not protect a place, care does, and care starts with seeing clearly. That may be the quiet achievement of the 2018 dives. They replaced guesswork with observation. They let the world see the Blue Hole not as a symbol only, but as a real place with a structure, a history, and consequences. There is a humility in that too. The expedition did not come back claiming the hole had been conquered. It was mapped more fully, not exhausted. Understood better, not finished. That difference matters because it is the difference between exploration and performance. A true explorer can say, "This is what we found, and this is what we still do not know." The great blue hole deserves that kind of honesty. It is too old, too layered, and too physically eloquent for cheap answers. It asks for patience. It asks for careful looking. It asks us to hold wonder and evidence in the same hand. So where does that leave us? It leaves us with a place that is more extraordinary after explanation than before it. A place that was once dry, now drowned. A place where bright tropical life gives way to a dark, lifeless lower chamber. A place where geology and chemistry guard memories that human eyes reached only recently,